tonight is trigonometry part 2. I'm going to recap the standard form of a sine wave that we looked at last week. Then I'm going to introduce the concept of phase shift in sine waves. And then do some calculations involving sine waves that have got a phase shift portion to them. Okay, so drill. For a sine wave expressed as y is equal to a sine omega t, what are the constants a and omega? What do they represent? A is what, George? Amplitude, or the maximum value of that sine wave. So to tell you what the peak is, if we talk about a voltage, that would be the peak voltage. And what is omega? Angular frequency. What are the units of omega? No. Remember what form that's usually in? Something times pi. Radians per second. Yeah, because it's a number of pi radians every second. So angular frequency. If y is equal to 28 sine 40 pi t, what's the amplitude of the waveform? 28 volts. Just that number there. What's the frequency in hertz? Yeah, it's 40 pi over 2 pi, 20 hertz. Who said y is at over 2 pi? Because, Adam, omega is equal to 2 pi f. Yeah, so you divide through by 2 pi. Alright? So in that function, omega is the bit that says 40 pi. And what is the period of the waveform in seconds? T, the period, is 1 over the frequency, so 1 over 20 equals 0.05 seconds. Yeah. So that's a link back into what we did. Moving on. Phase difference. Food. So the blue waveform, this one, has a leading phase shift. And students get confused with this. They think positive. It's ahead of it. Yeah. The green one has a negative pi over 4 phase shift, so it peaks pi over 4 radians after the red one. Yeah. All happy with that. So that's how you would express two waveforms that are, they could be the same amplitude and the same frequency, but they're not in line with each other because there's a phase shift. Alright? Yeah? So what we're going to do is have a look at a couple of problems around with phase shift. Alternating current is given by I. Okay, something else I want to cover with you is that function is given the current at an instant in time, an instantaneous value of current. So if we put a time t in that function, it will tell you what the current would be at that time. When we talk about instantaneous values in engineering, we use lowercase letters. So a peak current would be a capital I, an instantaneous value at time t would be a lowercase I. So we've got I is equal to 30 sine 100 pi t plus 0.27 amps. And it says find the amplitude as the first thing. Yeah, it is this number here. You just have to know that that function is in the standard form of I is equal to A sine omega t plus or minus alpha. It's in that form, so you just pick the amplitude out of the standard form. .30 amps. Yep. B. We'll find the frequency first, because you need to do that to find the time period, in my opinion. F is equal to, yeah, let's write out where it come from though. 100 pi over 2 pi. So that is, I'm just going to, for completeness, so you, when you go back to it, you understand that's omega over 2 pi. 100 pi, that's omega, the bit before t, over 2 pi equals 50 hertz. Adam, we talked last week about not evaluating pi unless you have to in your functions. That's a typical example of why you wouldn't. You do that calculation, that cancels out anyway. Yeah? So normally only evaluate pi right at the end. So you get the frequency from the omega value, always remembering f at omega is equal to 2 pi f. If you remember that, You can always get that. C, period. How do we calculate the period? T, capital T is used for the period. 1 over the frequency f, 1 over 50, 0.02 seconds, which is 20 milliseconds. Is probably a nicer size unit to have it in. Yep. What else does it ask for? It asks for the phase angle in degrees. So we want to know alpha. Alpha equals 0.27. How do we turn that into degrees? Over what? Someone said something about pi. Divided by pi times, sure, 180. Pi radians is 180 degrees. So you can use either 0.27 over 2 pi times 360 or 0.27 over pi times 180. Either will work. What's the answer? 0.4 degrees. Okay. About degrees equals 60. And by 60, because that's 60 minutes. What's the shift function for sine on your calculator? Sine to the minus 1. So I've got to do sine to the minus 1 of both sides. That'll cancel out the sine on this side. It will mean that alpha is equal to sine to the minus 1 of 0.9 over 2.5. Are your calculators in radians, gentlemen? Well, they should be. Calculators should be in radians, remember? We were using omega.
0.3.